Hello everyone, welcome to my YouTube channel. And the question for today is integer to Roman. So, uh, given a number n, we have to convert it into its Roman interpretation, and we know standard Roman interpretations of the numbers like I for 1, V for 5, and X for 10, and so on and so forth. Alright, so for example, if a number is 2, it's written as II, so as we know all that. So if it's 12, then it's written as 10 plus 2. So these are the things that we know. And for the numbers like this, we have to place, like for 900 we have to place like before that m, like for 900, 1000 is for m, and if we place c before m, we get 900. So these are the things that are given to us, and we have to convert it into the Roman interpretation. What else is given to us in the constraints? Let's see. The in constraints it's given to us that the number would be from 1 to 4000, so it can't be 0. So it will start, it can be 1 also, so one test case will be 1 for, but no test case for 0. As you know, there is no representation for 0 in Roman. So yeah, so that's the constraint given to us. So this is the question that we have to solve for the day. Let's see how we're going to solve this question. Now, for the approach for this problem, we will write approach later on. Let's see with an example how we'll solve it. So this is the number that we have to make its Roman interpretation, and this number can be break down to 1000, 900, and I say 50, then 40, and then last is 5 and 3. Alright, so this can be break to like this. Why I have used this representation, I'll tell you later on, and it would be very helpful. So 100,000 plus 50, 40, 90 plus 95 and 98. So this can be broken down like this. Alright, and we have used this because these will be our standard representations. Why I have taken a 40 as a standard representation? Because for these numbers we have to insert two values, like, and it would be inserted in the backward of the 50. So as we know, for 50 it is, so for 50 is, we can see for 50 it's L. So 50 will be L, but for 40 it would be XL. All right, are you getting my point? Similarly, for 90 also we will have one standard representation, and that would be C for 100 and X for 10. So for standard representation would be like this. So the numbers that are, that have the representations like this, we will also be storing them, because it will be the standard value. Because if we are going to append more and more numbers in a head, we can do that easily. We can do easily like this, 5 and 3. So we like phi for 5 and then 1 1 1 for 8. All right, so no need for these things. We have to store in the table these values and also the previous values. Like for 900 it is CM, and for 400 it is, for 400 it would be CD, because D is for 500, and like that. For then for 90 also, 90 it would be XC, and for 40 as well we will be storing it, and it would be, for 40 it would be XL. And now we have 9 and 4 only. So for 9 it would be IX, so 9, and for 4 IV equals to 4. So if we store these whole values in an array, then we can solve any problem. We can convert any number into its Roman interpretation. Now let's see how we will do this by an example. We have to keep this table in our mind and then solve the problem. All right, so let's see. So let's see. Suppose the number is 1994. Alright, we will compare it with the maximum value, that is 1000, and we will see that if the number is greater than 1000, we will just subtract 1000 from it, we get 994, and for the corresponding value of 1000 we will be adding m to our final string answer. Alright, then we will see that, again we will see that if it's greater than 1000, which is not, so we will look for the previous value. So the previous value would be now 900. Since it's greater than 900, we will just subtract this value and we will get 94. Alright, for and the corresponding value for the 900 would be added, that would be MCM. Alright, now we have 94. Now we will look for another. 500 is greater, 400 is also greater. Now we go for 100. 100 is also greater than 94, but 90 is not greater, so we will just subtract 90 from it. So 94 minus 90, and what we have before was MCM. So as soon as we subtract 90, we will add its corresponding value from the table, which is XC. Alright, so XC would be added, and now we left with 4, and then we compare it with, it's greater than 50, no, it's greater than 40, no, it's greater than 10, yes, it's greater than 10, it's greater than 50, but these values are, 10 is greater than 94, 4, no, 5 is greater than 4, no. Now we will go for 4, so it's greater than or equal to. All right, so 4 is 4, till the we get 0 we will just subtract the value and we will loop back. So if the number is not greater than, in the initially, if number is not greater than 1000, we just move to the another value. All right, and if it's greater than 1000, we subtract it. All right, and hope this is clear, and this is the representation for 1994. All right, let's take another example here over here, in which we can solve a number like 571, suppose. All right, so first we will check if it's greater than 1000, no. If it's greater than 900, no. If it's greater than 500, yes. So 500 minus this is 71, and for 500 the representation would be D only, so D would be added to our final answer. Then we will check with the 500 again, no. So because once we subtracted, it could be that it can be greater in case of suppose 3000. All right, so if we subtract 1000, it's still greater than, so likewise we have to again check for that number as well. So this could be the case sometimes. All right, and we am not adding the 4000 like that things, because the numbers given to us is from 399 only. So for 4000 representation, we have not adding anything. All right, only for 900, 40 and 400 case we are covering, as well as 9 and 4 case we are covering, not for 9000, 4000 and things like that, because in the constraint it is given that it would be a value to be up to 399. All right, that's the case, a different case. So in this case, like for 3000, we will keep on checking, so we will check for this value again. So if it's not, then we will move to the previous value. So 500, then we get 100, 400, no, 100, no, 90, no, 50, yes. So 50 will be subtracted, and we get the result 21. So for 50, it what is the representation? It will be L, so L will be added. So now 21. Now we'll check for 40, no. 10, yes. So we will subtract 10 from it, we'll get 11. So we will add X. So yeah, so here again it's like greater than 10. So yeah, that's the case which I was talking about. So again X would be added to that, so DLXX, and we left with 1 only. After that, when 11 10 is subtracted, so 1 only. So yeah, these kind of cases I'm telling you about, that where we have to check again. It's not that if we subtract and then we move to the previous value in the array or the table that we have. So we have to check for that value as well. So for 1 it would be now, so it would be I as well. So this would be the binary representation. I hope this approach is clear to everyone, and it would be more clearer once we see the code for this. So let's see the code. All right. So here is our solution, and we have taken one array in which we have stored all the values, and I have told why we haven't stored for 9,000, 4,000 as well, because the numbers range constraint given to us is like this here. So this is a string where we have stored their corresponding value for 1000 m, 900 cm, and so on and so forth. Now we have taken a result string in which we are going to append the value symbols that are corresponding to the value. So for int I equals to 0, I less than values dot length, we're going to traverse this array, and we see that as long as the number is greater than the value or greater than or equal to, we will do nothing. We will just subtract the number value and we will append it in the symbol table. As soon as it get less, we will then look for the another value. All right. And finally, after traversing whole of the loop, we will just convert it into string and return it. Let's try to submit this code. So yeah, as you can see, it's accepted. So if you have any doubt, you can ask me in the comment section, and please like this video, share it among your friends, and subscribe to my YouTube channel. Thank you for watching. Bye bye.